Hello students, in this lecture we are going to learn about some basic things about refraction. Okay, what is refraction? Refraction is basically when a light travels from one medium to another medium. This phenomenon is known as refraction. Okay, suppose we have, this is the surface, right? Medium 1 and this is what? Medium 2. So there are two mediums, suppose, okay, and a light traveling in this direction. So this is my incident ray. Okay, so light is traveling in medium 1. Okay, just like reflection, we will draw a normal at this point. Now, okay, it can, there are three things which can happen. Okay, one, either it will go in the same direction. Okay, then we can conclude that this medium 1 and medium 2, they are same, there is no surface here, right? So but we are talking about two different mediums, so it will not happen. Then another thing is, it can change the direction and it moves towards the normal, and this angle is smaller than this angle. This is known as bending towards normal. The light is bending towards normal, right? Another thing which can happen, let us draw it here. It can move away from the normal. Okay, what is this angle? This angle is I. This angle is R. I, R, right? So when my I is greater than R, we say it is bending towards normal. And when I is less than R, bending away from normal. Okay, so these are the two cases which we will study here, right? So this is known as my refraction. What is refraction? When a light travels in one medium and enters the another medium, two cases can happen. Either it will bend towards normal or it will bend away from the normal. Okay, now which things decide whether it will move towards the normal or it will move away from the normal? That thing is known as refractive index. Refractive index. Okay, so every medium has its own refractive index. Suppose for medium 1, we can say it is N1, for medium 2 it is N2. Now we will see how my refractive index will decide whether it is moving away or moving towards. Okay. Okay, let us first learn the laws of refraction. What is the law? Law say, the first one says that my incident ray, my normal ray, and my refracted ray. Okay, these are the 3 rays here. They all lie at same plane, at the point of incidence. Okay, so basically this is my point of incidence. At this point, my incident ray, my refracted ray, and my normal ray, they all lie on the same plane. Here also, this is my point of incidence. Okay, and what is my second law? It is also known as Snell's law, right? Snell's law say that sin I upon sin R is equal to a refractive index refractive index of medium 2 with respect to medium 1. Okay, we will learn lots of things in detail about this law. Alright, so refractive index of M2 with respect to M1 is also known as sin I by sin R, or if we can write in a different manner, we can say that sin I upon sin R is equal to N2 by N1. It is also written as the refractive index of medium 2 with respect to medium 1, right? So we write Snell's law in this form also, right? There are other definitions also for my refractive index, or you can say this is also known as a relative refractive index. This is what a comparison of refractive indexes, right? So we can say that it is a relative refractive index. So it is, or you can say refractive index of M2 with respect to M1, right? Okay, I usually write this question in a form like N1 sin I is equal to N2 sin R. Why? I tell you, because it is easy to remember the other formulas also, right? Now let's understand what is this. N1 sin 1. N1 sin 1 means N1 is what? The refractive index of medium 1, and I is what? The angle in that medium only. So product of the refractive index of the medium and the sine of that angle is equal to, again, the refractive index of another medium and the sine of another angle, right? Same angle. So you can say that the product of refractive index multiplied by tan theta is always a constant. This is another formula, that the product of the refractive index and sine of the angle made by the ray with the normal is always constant. Okay, right? So we have now I will write two more formulas, but before that, what we will do, we will learn about light. Okay, light has three things. One is wavelength, frequency, and speed, right? Wavelength lambda, frequency mu, speed v, or in case of air it is c. And one more thing, we know the formula, v is equal to mu lambda. This is our formula which relates these three quantities of light. Okay, now whenever a light enters from one medium to another medium, one thing that doesn't change is my frequency. Frequency doesn't change, right? Speed changes, wavelength changes, but frequency remains the same. So another formula of refractive index or relative refractive index, we can write another formula. You write the Snell's law as N1 V1 is equal to what? N2 V2, right? What is my V1 and V2? V1 is speed of light in medium 1 and V2 is speed of light in medium 2. Okay, now let us see here what is V1 by V2 here. So if you compare this, N2 by N1 is equal to what? V1 by V2. Now let us take some cases. Case 1, when V1 is greater than V2. What we are saying? We are saying that when light is traveling with some speed v1 and it enters the another medium and the speed decreases, my v2 is lesser than v1, so my speed decreases. So by this ratio we can say that our n2 is greater than n1. When n2 is greater than n1, by this law we can say sin I is greater than sin R, right? And sin same are there, so I can be written as greater than R. It means this angle is more and this angle is less, so it says that it is bending towards the normal. So speed decides the bending, right? When the speed decreases, it will move towards the normal. Second case, suppose speed is increasing, means v2 is greater than v1, we can say that n2 is less than n1. Similarly, sin I is less than and R is greater than I. So this is the case where the light bends away from the normal. My R is greater than I, right? So speed decides, actually refractive index decides the speed, and hence the speed decides whether it is moving away from the normal or it is moving towards the normal. Clear? Now if you see this formula, we can write this equation as n1, since frequency doesn't change, so I am writing it only nu. Lambda 1 is equal to n2 nu. Lambda 2, the frequency will get cancelled, n1 lambda 1 is equal to, right? Remember all these formulas of refractive index, right? So n1 v1 into v2, n1 lambda 1 into lambda 2, and this, right? One more thing, that if a light bent towards normal, we can say that the medium 1 is rarer medium and medium 2 is denser medium. Similarly, if it moves away, then we can say denser to rarer. So refraction can be said that when a light travels from rarer to denser, it moves towards the normal, and when it moves from denser to rarer, it bends away from the normal, right? Suppose light is traveling in this direction, right? If you reverse the direction, suppose starting from here, okay, it will follow the same path. If you reverse the direction of light, suppose it is moving from denser to rarer now, so it will bend away from the normal, and if you follow the same rule, Snell's law, simple, this time again n2 sin R is equal to what? n1 sin I, right? We will follow the same thing, that product of the refractive index and the sine of that angle is always constant. So when the light is traveling in the reverse direction, we will follow the same rule, okay? So what we can say here is, my n2 by n1, we can write it what? 1 upon n1 by n2, right? What is this? This is refractive index of here, right? Refractive index of second medium with respect to first medium. What is this? Refractive index of first medium with respect to second medium. So these are what? Reciprocal of each other, right? When you are comparing the two mediums, we can say that refractive index of one medium is always reciprocal as compared to other medium is always reciprocal of the refractive index of another medium as compared to the first medium, right? What is the refractive index of air? We take it as 1, right? Basically it is 1.003. For calculation purpose we take it as 1, right? And for all the other medium it is always greater than 1. Remember this thing, that your refractive index will always come greater than 1 for other medium, right?